Something I've noticed about the conference so far is that there's been a lot of sort of like looking back, kind of retrospective about what it's been the last 20 years of open source Erlang, and there's something that I've been sort of doing for about 20 years, and that's been kind of like packaging and getting things to our production systems. In fact, the first job I had, I was kind of a release engineer, and I got to move things to production, and sort of this is how I did it. I don't know if anybody remembers these. I had to go and find a picture on Wikipedia, but this was a Jazz drive, which basically could give you like a gigabyte of storage. And my first job out of college, which is in the mid-90s, was being a release engineer for a company. And they had just built a website for PacBell, and every day at 5, I would get like a flurry of emails from everyone who would say, hey, I got this file to go out today, and it's over on this NFS mount, and here's this attachment, and oh, can you change this thing over here and apply this patch over here? And I would take all those changes, 5 to probably about 9 p.m. and just kind of get them all together, get them packaged up, put them onto this drive in one room. Then I would pop the drive out of the disk. I'd walk across the office to the corner where there was one computer, and it had a single line that went to our data center. And I would plug it into a drive there, and I would start the long process of like transferring files, up this, I don't know how fast it was, to our data centers, deploy them, and I'd usually finish my day about 12 to 1 in the morning. So that was kind of a sort of interesting look back at the way things used to work. We had an air gap system. Like you couldn't actually get onto your production systems. Nowadays we're sort of, we have things like SSH. We can get to all our systems at any time. We're always on the network, so we can kind of get everywhere. But that didn't stop with me sort of like dealing with packaging systems and getting things into production. For many years, I've gone on. So in the 90s, I worked for various Idea Lab companies, and we had a system called Wigwam that we used to kind of put together and package up our systems for production. Later on in the early 2000s, when I worked at Overture and Yahoo, developed another system, and this one was called Skeletor, and it was all about trying to work within Yahoo's packaging infrastructure and getting things sort of built with their types of packages. When I left Yahoo, I went and worked at a small startup with some friends called N54, and we took the kind of parts we liked of Skeletor and created a new system called Framework, distinguished by the E. And we used that for years to sort of package and build RPMs, and and then recently at OpenX, I've kind of looked back and decided that Framework has been great, but I really need something that's a little more modern. So I've sort of developed a new plugin to help kind of build RPMs specifically for Erlang services. So I want to take a step back and say, well, when I'm talking about services, what am I talking about? I'm really talking about sort of like Linux services. And these are things that I looked around for sort of like true definitions, didn't really find much, but kind of conglomerated a few together and added some of my own things to come up with this definition. So Linux service, in my mind, is a process or set of processes that run as a daemon on the system, and they're integrated with your init system, whatever that init system might be. Services, they can be started and stopped and reloaded via scripts. They usually adhere to file system standards. They put their files into sort of standard places. They log to standard places or have functionality to log to syslog systems. And then a couple I've added is I feel that to have a real service, you have to have ways to know how to inspect it, as well as sort of debug it. So when you take that in the context of an Erlang service, what has to be part of your service? Well, there's the parts that you kind of are aware of, the release parts, the Erlang release parts, so the Erlang runtime itself, the beam files for your particular application, and there's always scripts that are generated that'll start and stop the Erlang nodes. That's great. That's a bare minimum. You could kind of take that and sort of like drop a tarball somewhere and use those, but it doesn't really integrate with everything else. So, the parts that I really want to talk about is the integration with the system service infrastructure. So integrating with the sys5 init system, integrating with systemd, integrating with a supervisor D system, whatever other things you're using. Maybe running inside of container, which usually means sort of running in the foreground. And then, possible integration with the system logging service, so the ability to interact with syslog. And then also things that I talk about when I talk about inspectable and debuggable portions are things like being able to get a remote shell to a running node, being able to then, within that shell, run tools like recon, as well as being able to sort of evaluate code on that running node, which is often useful to kind of like have cron jobs which maybe inspect something and log to Nagios, or various other ways you integrate with an overall system. But why would you package your service? Like maybe you're in the tarball that you get from making a release is enough for you. Well, I like to look at packaging as like they provide a lot of things. So they give you an amount of consistency in that it's very easy to figure out, say, what version of your package is running on all of your systems very quickly and easily. RPMQ or depackage similar commands. You can basically say like, okay, what's running on this box? I can in a loop SSH to a ton of boxes, see what's running everywhere, make sure they all are sort of consistent. There's reliability. If it installs on one machine, it's probably going to install on most of the others because they're hopefully all running kind of the same baseline OS. It's repeatable. It pretty much always installs in the same way. There's a transaction that happens at the RPM layer that's there. I think there's a low barrier to entry for most people in that, like, if they want to try something out, they can just download the RPM and install it. And they don't need to wrangle with Git or build systems or all these other things. They just have like, oh, here's a nice package I can sort of use. And they're enterprise ready. And that, like, if you're packaging something that you want people to use, if it's packaged for Red Hat and can be run on CentOS or Red Hat Enterprise Linux, like, it's a lot easier for an enterprise that's using those to adopt it. So I did a sort of survey and looked kind of like who is already packaging things and sort of what are they packaging. And so I put together a list here of some of the popular and even not as well-known ones. So React, it's been packaged for ages. Their Basho's sort of no longer involved there, and so it's laid dormant for quite a while, but they built a pretty neat tool called Node Package that helps you sort of package up things. Node Package has been used by at least one other project, VernMQ, which I don't know much about, but it's another sort of message queue broker type systems. Rabbit has been releasing Debians, RPMs, everything for sort of ages. There's a product called Early Video from Flusonic, and I only know about it because I came across EPM, which is I'll get into later, but it's a way to sort of package code similar to the way FPM works on the Ruby world. Sonic Pi, which Joe mentioned before, they release a Deb, they release a macOS DMG. These are all kind of well packaged, well distributed. Wings, which is like an older Erlang system that has been around for a while. Like, it at least has like some self-extracting shell scripts for the Unices, and it has a DMG for Mac OS X. CouchDB, they release pretty much Debs, RPMs, Windows exe files, DMGs. And then at OpenX, we've been sort of releasing RPMs internally for about 12 different services for the past sort of 8 or so years. So that these kind of break into, like, if you kind of look into how these things are packaged and what's kind of being set up, I've kind of come up with kind of 3 general classes. So the first one is what I like to call the sort of distribution style. And this is what the operating system vendors are using when they sort of package up Erlang, usually Erlang OTP runtime and its packages. And if you look at sort of like, do a search on Fedora packages, you'll find something like this where basically they've packaged up every single application that is in OTP as a separate RPM. So you end up with something where you end up with a lot of RPMs. These little boxes on the side represent just different RPMs. And I've sort of added some few in here to kind of go into what I'm going to like sort of demo a little later. So you end up with like, okay, one package for the runtime itself. You usually have one package for each sort of particular separate Erlang app. Your dependencies are all managed by the dependency management of the system package manager. The nice things about this is only the packages you really need are installed. You can upgrade the Erlang packages separately from your applications. So if a new version comes out from the operating system, you can usually just upgrade. You may be able to upgrade parts of your application. So if your application is actually using some of these other parts, you might be able to kind of just like upgrade Cowboy or upgrade some other package that you've made. Now, some of the drawbacks are, well, there's lots of packages to manage. The dependencies are sort of determined when you install things. The package management will resolve everything, and that can lead to issues if people deprecate or move packages around in your yum repos or apt repos. And most of these, when they're the distribution style, they're all relying on whatever the distribution's like mode of making packages are, which on the Red Hat systems are like spec files, and it's a whole nother sort of thing to kind of look at. Of the ones I listed before, RabbitMQ is the one that I think kind of releases in this way. And I mostly know that in that we use RabbitMQ in a few different places, and the version of Erlang that is installed on all those places is different on every single one. And I'm like, okay, so this one's still using like R14, and this one over here is using R13, and this one's using like 17 or 18 or something. So the second one is kind of the like node package sort of release style. And this is like where actual Erlang releases are being built, and everything is sort of being included in this like one package. So this kind of looks like this. We've got sort of a big package that represents the service, and then within that we've got all the sort of pieces that we need. And the ERTS is kind of a different color there because it's optional to be left in and out, especially if you use RelX. Like you can embed it or not embed it. Systems like React, like they embedded it because they had their own customized version of it. I found like CouchDB, I think, also embeds it just so it's like not an extra dependency, and they can sort of manage the version more. So if you really want to manage your version, this is a good style to use. The dependencies are usually managed by your build system, like rebar 2, rebar 3, maybe erlang.mk, like you're doing it at build time. The nice thing is that like for building, your only sort of prerequisites are like an Erlang runtime system and all the OTP tools, as well as like a build tool of rebar 2, rebar 3. You end up with single package, minimal dependencies. Some of them integrate with several different operating systems, Node package being the one that has the most integrations. But when you kind of look at some of the different ways in which people are putting these together, oftentimes you run into complications like really quickly. Like Node package is using like rel tool and rebar 2, and if you're using rebar 3 and releases and relx, it's like a totally different set of things. So usually there's some like extra make files or other things. Some of them are using spec files still and just pure make files. It's just kind of all over the place. And a lot of them, like the documentation as well, digging through templates, spec files, things like that. So then the last one that I want to go into is framework. And while I'm sort of in the process of kind of sort of deprecating our use of framework, I do think it's good to sort of look at it because it's sort of a hybrid of a couple of these things. So in framework, we end up with sort of one package, which is the Erlang OTP release. So that's Erlang plus all of its like dependent things, like one package. It's easy to install. You install Erlang, you get the compiler and the runtime and sort of all that stuff. And then for each of the individual packages that you are using, everything gets sort of packaged separately, and you use the dependency management of the operating system to sort of manage those things. So again, like kind of that first example, like only the packages you need are installed, other than, well, Erlang has everything, so you get these, many packages you don't care about in there. And so I was happy to hear that things like Orbor and COS are moving out. I'm like, I've never even looked at them, and I have no need to ever look at them. They're in there for no reason. Now, you can also, again, you can upgrade Erlang separately from your other apps, and we sort of did this, quite regularly actually for a while, where we would have lots of things that were built with a particular version of Erlang. I think back like R14, R15, and then, we want to upgrade to R16, so we can just upgrade. And now our runtime systems are running 16, and even though everything was compiled with 15, everything works. Until someone accidentally like compiled something with 16 and then tried to put it on a box that still had 15, and then everything broke. And then I had to sort of come up with some ways to fix that. So you can upgrade parts. Again, the cons are, well, there's lots of packages. Again, dependency resolution is at install time. And then, the worst is that, like, since you're usually using the system level packaging and those really support ranges, depending on when particular subcomponents are released by different developers, you might end up with slightly different versions of things. So if you go and actually take a look at packages installed, you might find like, I've got like a minor rev difference of ranch on some particular box, or a minor rev difference of logger, or this or the other thing. Most times those don't matter, But if you ever want to be like, well, is everything kind of the same? It makes it hard because you're like, oh no, nothing's really exactly the same. But Framework actually has a few other tools that it relies on to kind of like put together this service infrastructure using Framework. So there's four packages, 4 libraries that are used. So Framework itself is really just a glorified templating system that is able to construct RPMs without developers really having to know. Also, it supports Deps as well, but it allows you to kind of not have to worry about any of the details around any of these packaging systems. You don't need to know how they're built or what they're built. It sort of abstracts things like dependencies into a common format and just sort of behind the scenes will build and construct packages for you. It also has a bunch of languages that we like supported. So you can do C or C++ or Java or Erlang or Perl or scripting things or just tons of stuff, and they all build in the same exact way. So that's really has been nice when you are working in a very heterogeneous world. But it's built on top of like auto tools, and so anyone getting in there and looking at it usually ends up like, I don't know, squinting when they get to the M4 that has shell embedded, that has Perl embedded, and is trying to figure out why the quoting is like, crazy. So then there were 3 other tools that were built to kind of like manage. One of the big things that Framework was trying to do via ErlRC was it was trying to integrate system package transactions with Erlang hot code upgrades. When you upgrade one of these sub-packages, the idea is that it goes through a release handling process of Erlang, and it goes through and hot code loads just that one application, and it does things like generates app-up files and does a lot of this stuff. And it also sort of manages like a boot sequence order, where it pretty much does what Ensure All Started does now, but it did it sort of like 10 years ago before those things existed. And it's great and it works, except that it takes a lot of finesse to do any sort of like hot code upgrade, as I'm sure anyone who's tried to do it knows. And it's not something that you're often like doing a great job testing. And it's the one part where you can like really sort of like, get stuck and things are messed up. So while it's there and it sort of should work, we don't use it and haven't really used it. We've taken more of a sort of rolling restart approach. We still just like, install a new version of a package, but we kind of bring down the system, install the new version, bring it back up, and then that makes things a little bit better. Erl start is a set of like, scripts that allow you to just start, stop, and interact with the node itself. And then Erl node is just integration with the Red Hat CentOS like sys5 sort of support. So what I want to do is I wanted to kind of like go through, not in a true demo, but just go through and say like, okay, what did this look like in practice? So if we have a toy problem, we just want to create a cowboy hello world app using Framework. Well, we actually had a lot of steps. You had to have your prerequisites. You had to have Erlang and Rebar. You had to have Framework, and then you had to have the Erlang Rebar template. And this is all Rebar 2, because we basically like have mostly been Rebar 2 for pulling in external dependencies and building stuff for a while. And are just now kind of moving to Rebar 3. Then you had to get Erl node. So Erl node kind of relied on a lot of things because I wanted to have certain tools available on all of our systems. So it had, ErlRC and Erl start. It had Gold Rush because Logger needed it. It had syslog, and then it had Logger syslog, and then it had cecho and entop and recon kind of all baked in. And then for your app itself, you would need to sort of like build the prerequisites that you want for your app. So in this case, it's Cowboy app. You need cowlib, branch, and cowboy. And then you need to actually create and sort of build your app. So there's actually a demo repo that has a makefile that sort of will do everything if you want to try to replicate this. I've only done it on CentOS 6. It should work on 7. But the first thing in the demo is like there's a make prereqs, and these builds Erlang, Rebar 3, and Rebar 2. If you want spec files that build you Erlang and Rebar 3, like they're pretty simple spec files there that actually work by cloning and checking out a tag. So you just give it the specific version you want, and you wait a couple minutes, and you get basically these packages. The release on these all is test 1 because they're test packages, and that release ends up being a true number when we actually sort of build packages. So first I had some like existing framework packages, and I just wanted to show kind of how these things are built. So the first thing is Framework itself is booting. So Framework's package is actually called FW. So if we clone it, check out a particular tag, and then we run this command that's basically, I highlighted, bootstrap configure make package. This is kind of every single framework package. These are the commands you use to build things. Like, it doesn't matter the language. It doesn't matter like what is happening behind the scenes. Bootstrap runs all the autoconf, autotools stuff to kind of set up your environment. Configure is like a standard. If you download a tar and do configure, make, install, it's the same thing. Configure is running autoconf. It does a bunch of things like checks for various versions of things and checks that all your dependencies are installed. And then make package actually sort of builds an RPM and puts it into this FW package out directory. So I sort of build and install framework. I then build and install the Erlang rebar template. And then, after this, I would also build and install ErlRC and build and install ErlStart, because they're the kind of next two in the line, but they look exactly the same. And instead of having slide after slide of the same, I'm kind of just giving everyone the highlights. So then you get to the first third-party package that you want to sort of turn into an RPM. And Framework tries to make this really easy. So if we start at the top, you have to give it a name, and this is the directory name that it's going to be in, and it's going to be usually the name of the application is the best thing. It works the best that way. You don't have to customize anything. I'm turning off revision control integration, so the revision none means don't integrate with revision control. Another nice thing that Framework does is it integrates with your revision control and tries to prevent common mistakes. So you can't release packages where you have unchecked in files. You can't release packages if you've already released and tagged that version. It tags things when you're releasing them so that you can always kind of create reproducible things. You specify the template you're using. There's an option called with build prefix, which if you look down at the bottom, you notice that it says Erlang 18 Gold Rush. So that will calculate that build prefix to be Erlang, the version, and then stick it in front of the package, and it makes the packages name that. This is mostly useful to prevent that error I talked about before, where I'd have an R16 built package and try to put it onto an R15 host, and it would fail. By prefixing them all with the version that they were built with, we were able to kind of manage and say okay, well, this system has all Erl 18 packages on it. This one has all 16 packages. Then you can give it a git path to wrap. So this is where it's going to pull its source from, and then the tag that it's going to use. And once you've run that's initializing a directory, which has all the framework, hooks and everything in it. You can go into that directory, run again, bootstrap configure make package, and you're going to get an RPM, which you can just sort of go and install. And what does that RPM look like? Well, if we actually kind of just take a quick look at it, the top is this ErlRC integration, which is just a little file that ErlRC can read when it's booting things up to know what things are managed by ErlRC and give it a sort of root set of things to start. And then it sort of has all the Beam files and app files, and it's, I truncated it. It includes everything you would expect. And it all is going into userlib64 Erlang, which is where my Erlang package is also installed. So everything is all in the sort of common directory tree, common path. It means that every package built this way, if you just run Erl and go into a shell, you can find every application in every module, which is very convenient from a development perspective often. So again, another example of a framework package where we actually have sort of dependencies. The only really change here is that bottom line where there's another with Deps, and you give it a list of the sort of applications. Framework will sort of look and figure out that you specified a build prefix and you specified with Deps, so it'll actually put in the appropriate dependency, and you can kind of see that here if you actually look at after we've installed this, and you can see that it's got Erlang 18 Gold Rush, and it's got the test version. And when you actually build with this, you'll see that Framework actually warns you and says, hey, there are test versions in your environment, and it's it trying to tell you that you're trying to package something that itself is relying on something that is unreleased. So I'm going to skip a few because essentially it's the same kind of thing over and over and over and over again. If you want to go and look at the Makefile, it kind of has them all spelled out, and you can sort of see. But I just go through and sort of build everything. And then I can take a look at sort of what's on my system so far. So RPM QA, I grep for that test thing, and then I can just sort of sort it, and I see that I've got Erlang. I've got all these Erlang 18 prefix packages, which are all my Erlang 18 applications. I've got Framework and the FW template Erlang rebar and rebar 3. I haven't used rebar 3 yet, but that's for the future. So now I want to actually sort of build my application. So again, another FW init call up top. This time it's like my web app. In this case, I probably, if I was doing it for real, would put in a revision control system because now I care about that part. Erlang rebar template, build prefix, cowboy's my dep. Like, okay, I'm going to cd into that directory. I'm going to remove the kind of boilerplate stuff that it just places in there from the template, puts in like a my app and my URL and my app HRL. I'm just going to copy. In the previous things, it like checked out stuff into these particular directories, so I just copy the hello world example out. I do a little bit of like renaming and sort of change everything to be my web app instead of hello world. And then again, bootstrap configure make package. I've got a package and it's installed. Now I'm going to actually start interacting with Erl nodes, so I can basically sudo service Erl node start. Takes a second, it's like booted up my service. And then I can go test it and say like, oh look, it actually is running, did everything get in there? So an example of like one of the tools that comes with Erl start is an Erl start eval command, where you just give it a chunk of Erlang, and it'll just sort of output it. So in this case, I'm just like, well, show me all the applications that actually are like running on the system. So you can kind of see that like everything's running that you would sort of expect to be running based on the original list, syslog, and all these things are running. In addition, there's a few other tools that I won't demo, but they are also there, which is like Erl start rem shell gives you a sort of remote shell attached to the running node. Erl start etop runs etop against the node. I don't like etop as much as I like entop, which uses like n curses and gives you like a top style, like processes are moving around and you can reorder columns and stuff like that. So I've got a way to sort of like run that against the running node. So I kind of got there. I got it all packaged, but that's it's pretty complicated, right? There's a lot of packages and a lot of things are happening. Now this is very manageable once you got it set up, because a lot of those things, like I would go through it like once, and then every few months when someone would have a new third-party dependency, I would add it to my one project which manages all the third-party dependencies. And over time, you got to the point where I had like 150 different third-party dependencies packaged, and then all of our internal systems had their layers of things packaged. So there was a lot of packages. And sometimes, like again, if you used range dependencies in some of your packages, then you weren't always getting the exact version you wanted. There was a lot of dependence around like when things moved to different repos and whether you could always see it. So it was easy to upgrade Erlang, but as I said, we ran into problems with like upgrades happening in the wrong order and people using newer versions for development before they were actually available in production and causing issues. It's not really based on anything standard. I mean, sure, Erlang itself uses autoconf, so you could maybe make an argument there, but in truth, like very few people use autoconf these days unless you're doing something which is like C code that you're expecting to run on a few different, Unices. And it has some documentation, but it's probably not sufficient documentation for most people's needs. So I was thinking, can I make these better? And I looked and I said, well, what do I want to achieve? Well, for me, like, I don't want to be the bottleneck for these third-party packages. Anytime anyone needed them, like, it was easier for me to do it and use Framework because I knew it than it was for most people to like pick up enough to like sort of get it working. Like I could get it working in 5 minutes, it would take them a couple days. So I would just do it. And then just the pure number of packages got to be like somewhat staggering, and especially if you're trying to manage like which versions are installed where and when, it gets to be a little bit troublesome there. So, and for developers, I wanted them to have standard tools like rebar 3, relx, and I wanted to give them flexibility to compile and release with different versions of Erts as needed. So, I looked what was really missing. I just needed a way to make a package. I had found these different versions, people using makefiles and spec files. I'm like, well, that's Framework hit all those. If suddenly you like dropped on the developers like, hey, you all need to learn how to write spec files, they're going to like revolt. Node package was cool, but it used the older release tools. Like it seemed very unmaintained. I kind of found a fork that used rebar 3, but it was just very complicated, and there was lots of makefiles. And then I found EPM, which I thought was interesting because it was like a single module. It would create RPMs or Deps like without any external tools, just by sort of knowing how things worked. And all you had to do was get your files into a particular directory, and it could just package them up as an RPM. So I said, what if I wrap this in a rebar plugin? And so that's where I created the rebar 3 build RPM plugin, which is in the OpenX GitHub, so if you want to go and look at it. And the idea is you take the RelX release, or more specifically the tar as a result of that, and you sort of package that as an RPM using EPM, and you overlay all these other bits that you need. So you have the similar prereqs. You really need a Erlang, and you need rebar 3 to sort of start with, and then you need a template, which I have provided, and then the plugin itself. And the output is going to be a single RPM. So we'll go through really quickly the sort of same example. You notice there's a lot fewer steps here because it's become a lot easier. So first you need to get your templates set up. So I just make a templates directory. I clone the template. I add it to my rebar config file. And then I run rebar new and oh, look, there's a new line there that has the service RPM as a custom template. And if we look at sort of what has been provided here, when I create a new service, it's got kind of standard like a git ignore and a readme. It's got a rebar config, which has a lot of stuff in it. It's got a little bootstrap script, which for the most part does nothing, but sometimes this is necessary if you have some external dependencies that you need to have installed because you're integrating with the system and you want to make sure it's installed for development. It's got a makefile, which really just is a few commands wrapping rebar calls. It's got config files, which are for the release side of things. So your system config file and your VM args. People familiar with releases should sort of recognize these parts. It's got this vars config file, which is kind of all of the different ways that you can sort of tweak the packaging of the system. Then it's got this priv directory, which has a bunch of stuff in it that it's dropped in there. So the init script is kind of the script that is going to go into your etc initd system to start and stop and do things. The admin script is a way to kind of have some extra commands that you're able to run, and I'll show that in a few minutes. I have kind of supervisor D, system D kind of integration scripts, which really just call the init script in a sort of foreground mode, and it was the lightest sort of integration with these systems that I could find. It's got this inner package config file, which for the most part I think is probably going to go away at some point and isn't really needed for most things, except to set up these pre, post, post, un scripts. And these are all things that integrate with the packaging system to kind of run shell commands before you install, after you've installed. So pre is before the package installed, post is run after the package is installed, pre-un is before you're upgrading or uninstalling, and post-un is after that. So if you need to set up a user, if you need to fix some permissions, if you need to create some extra directories, that's where you would do those in those scripts. And I think by default it kind of creates a user for your app with the same name as your app, and it does some things so that everything is kind of owned by that user. And then there's a little sysconfig example. So this is something that would be in etc sysconfig, and it's environment variables that might impact the init scripts and things like that. So there's some examples in there where if you're using CPU sets and doing scheduler stuff, you can kind of use that. So now we want to actually create our app. So we created the shell, but it's mostly a release shell. It doesn't have any code in it. So similar to before, I'm just going to make a source directory, and I'm going to copy those examples, and I'm going to kind of regenerate a custom one. I'm going to change the port just so I can have them both running. And then there's two changes I need to make to the rebar config, mostly in the dependencies. So the default dependencies look like this, logger, syslog, logger, syslog, recon, cecho, ntop. Then what I'm going to add down the bottom is this cowboy one. So it's an older version of cowboy because everything is rebar 2. I was trying to keep it the same as the other one, which is all rebar 2, and the newer versions of cowboy require a newer version of Erlang, and I've not really been using the newer versions just yet. It all should work, and I've tried some of it, but it's just, and we are using it for 19 versions and some other stuff like that, but for this example, I try to keep them mostly the same between the two. The second place you need to edit is down in the release section. You need to add your app there. And that's really it for the changes that are needed to be made. So then you go and you kind of run make package, and you'll see it pull all your dependencies in and sort of build the whole thing up, and it'll generate an RPM, and that RPM is going to be in build prod RPM. I can install it. And so before, where I had sort of Erl node, and I had a single Erl node that would start every app on the host, in this case, I am just starting my web app. So every different system service has its own start script. If they're all based on the same template, they're all pretty much the same script, but they're all separate. So I'll start it up, can run curl, it'll sort of give me hello world. And again, we can sort of look at like, okay, well, what's actually in that, RPM? I've got that init script. There's an etc, directory that has the sysconfig, the VMargs. They've been placed kind of in a central place. Got files in supervisor D, system D. They've all been put in their place. I've got this my web app admin script. And then, I've got a user lib64 my web app directory, and that's everything is sort of like underneath that. And if I just kind of cut a piece from down below, you can see that it's got like, it might have the source code for the apps. It's going to have like, the apps and the beams and things like that. And it's going to have, my app somewhere in there. And it's just going to be like a standard release, just the closure of things that you need. I provide via the admin a similar eval command because I found that evaling some code in your running node is often super useful. In fact, I had to get a patch made to the Relex node tool in order for it to support this, because all it had in the past was like a way to like separate different terms. Like you could be like, here's a module and here's a function and here's arguments, all as separate arguments, and it would sort of run it. And I like this where I can be like, here's a string which is Erlang, just evaluated on my node. And so, it's similar output. There's one or two sort of differences. There's no ErlRC. I think I have Sassel in this one by default. There's other commands with the admin. I've got a rem shell command, which will give you a remote shell. I've got entop, which will sort of run top on the thing. And really what the plugin is sort of doing behind the scenes is it's just doing a bunch of like file movements and sort of overlays. So one thing that Relex really doesn't support is, say, and it might be a useful addition, is adding a common prefix to everything. It just kind of puts everything into a release directory and assumes you're going to untar it to the right place. And when you're packaging something, you want to actually have the full path. So the plugin sort of supports the use of, if you use the word / in front of something in the files section of the release, it will sort of move all those things into the right place and untar the release into the right places with the user lib64 prefix, which you can override that in vars config, so that everything ends up in sort of one common tree below that section, so that when EPM comes in and just packages that whole thing up as an RPM or dev, it's all based off of what would be / and everything is where you expect it to be. And there's a bunch of little hooks here and there to do things like fix permissions and change user ownership and whatnot. So if you want to use it and try it out, like there's lots of that stuff there. The vars config file is very heavily documented in terms of what every variable is doing, and really it's not that complicated if you look into them. So the real question of all this is am I happier as the end result? And I think quite a bit. I put together this comparison to sort of like, look at it, and I'm like, well, Framework had its like nice things. Like it was normalized across many different languages. Like I could check out pretty much like a Python project or a Java project or an Erlang project or a C project, and I could use the exact same commands to build it. I didn't have to know that this one uses this, and I have to call, use pip to install something and then setup to build with the Python thing, or I use, this is a Maven Java project. And it was all sort of encapsulated in this like shell that would just call those things for you. It had the integration with the revision control system and checked against those common mistakes. And it did delegate dependency management to the system. Like I kind of like think of that as almost a pro in some cases, mostly because it did support ranges, whereas a lot of the rebar dependencies, in order to really do them, you either have to like lock all of them in, and it's a little bit annoying whenever you're upgrading things, or you need to just rely on master being the most recent, which is always scary. Now the rebar build RPM, like, well, the nice thing is it's just Erlang. Like, it doesn't call out to anything. It's just it's quite a big, beefy module, but it sort of just does it all. So there's very few external tools required. We did find one little area where we call out to Perl to do something, but that part could easily be taken out, and it's just, if you're interested in why, like, you can ask me about it. It's a bizarre problem, but. And one of the pros is we're ending up with many fewer packages, right? So when we're done, we have about 12 services. I expect to have about 12 RPMs total to sort of manage and know about and care about and have pipelines for and, there. Because Framework had these cons, like, well, it's written in these esoteric tools that not many people know these days, right? Like, I'm sure maybe a few of you, since you're in this, might know about the AutoConf tools and those things. Maybe you've used them, but in reality, not a lot of people have used those. And it had many, many, many packages. I think I did go through and I found like 149 different packages that I've created and done at various points. And the rebar 3 build RPM, like it has a few cons as well. Like it has light integration with the revision control system as much as rebar gives you, but it doesn't have any checks in place to prevent common errors. Like it'll totally let you release something where you have unchecked in changes. It'll totally let you release something that you've already released a version of that package. So you have to kind of like build those into the hooks outside of it. And actually a lot of our developers have, in that they've like heavily customized makefiles outside of it to do various checks to try to do similar checks, because once you have those checks, when they're gone, you're kind of miss them, because you're like, do something and like just go through the whole process and expect, and in the past something would have caught you not checking that file in, and now nothing catches you, and you're like, oh well, that file didn't make it into the package, whoops. And again, the cons is like the dependency management is sort of stricter. You know, there's no real range support. And yeah, so you know, what will the future look like? Well, I know for us, we're sort of in the process of kind of like bringing more containers into the organization, and that kind of has its own challenges of packaging and doing stuff. There are those that say, well, it's a container, I can do whatever I want in it. I should just like put everything where I need it to be and like release that. And we're kind of in that point where we're sort of in a transition point, and so I'm just saying like, we can continue to build packages for the foreseeable future, because it's just as easy to install a package in a container as it is on a host OS, and it's going to be more flexible in that way, and we can sort of just have our build system kind of locked in. We're creating these artifacts. If that artifact gets shoved inside a container for the release time, that's a deploy issue. It's not a packaging and sort of build time issue. So that's kind of pretty much what I have. You know, you can sort of reach me, DJ Nim, at most of the places. I have some links to the plugin and the template. And then if you want to try to reproduce like the demo output, there's a thing there. It's got some spec files and a make file, but otherwise is empty. And if you type make and wait a while, it'll, I think Erlang takes the longest. It takes about, I think, 20 minutes to build on my VM a version of Erlang. So great. Any questions? Awesome.
Well, thanks very much.